Everybody, this is Mr. Beckstrom, and today I'm going to go over kind of a chapter 1 review. We're going to be dealing a lot with the trigonometric functions. These are the ones that we learned in pre-calculus trigonometry, so I'll do a couple of problems here and go ahead and let you try to work on those, and then we'll go over a solution part of this. But before you do anything, make sure that you install the, this is the CDF player here, and you can find that in my math lab under chapter contents. And when you click on that, you'll see a Wolfram CDF player here, and you click on that. It'll bring you to the website. You'll have to put in your name, your school, your email address. So go ahead and put those in. And then you're going to see a little installing box like this. And it'll take a little bit of time to install. But once you install that, then you'll be able to bring up the ebook in my math lab. And we'll do that in just a second here. Alright, so once you have that installed, then you can go to direct chapters and sections. For example, we're going to do a couple of problems out of section 1.4 here. So you click on that. And now once you have the Wolfram CDF player, you can click on the interactive ebook. And the first time it's probably going to ask you, what are we going to open this with? And I actually had to completely close out my browser and reopen it in order for the Wolfram player to show up when we tried to open that section here. So once you have that set there and hit OK, you should be able to bring it up here. And just take just a second. And you're going to get kind of like a table of contents here. And this is all for 1.4, so they go over radian measures. So you can click the little caret here, open it up. They have some interactive tools to show you how angles work, positive angles, negative angles, and different other tools in here. It's very good. They also have quick checks where they ask you a question. Try to answer that before you actually look at the answer, but once you finally do, you can click to get the answer here. And so really the first couple of days of this class, it's going to be vital to go through, go in each one of these sections here, 1.1 through 1.4, and go through these little refreshers here. Try the quick check problems. If you can do it, just move on to the next. There you go. All right, so let's go ahead and do a couple of problems from section 1.4 just to kind of get us back in the flow of using the unit circle in trigonometry here. So first we're going to take a look at number 2 on page 48. This is in section 1.4, and it says, for the given angle theta corresponding to the point -4, -3 in the figure, evaluate the sine of theta, cosine of theta, tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. So these are all the 6 trig functions that we learned about. And real quick, let us do just a real quick refresher on why these trig functions came into being here. So if you take a right triangle, and we have a right angle, 90-degree angle. Now, because that's 90 degrees, these other 2 angles have to be acute, which means that they're less than 90 degrees. Why? Because if we had 2 90-degree angles, that would be 180 degrees, and we know that the sum of all angles has to be equal to 180. Therefore, the last angle would have to be 0, which it can't be in a triangle because then you wouldn't actually have a triangle. So we have these 2 acute angles. We can call them whatever we like. In this case, I will call this one A, and I'm going to call this one B. and we'll call this C. Now if we look at one of these acute angles, not the right angle, but we look at one of the acute angles, we can look at the ratio of the sides. So if this is little c, because remember little c goes across from big C, little a, that's side little a, and little b goes across from big B. So if I take any of these acute angles and I look at the ratio of one side to another side, there's going to be 6 different possible ways I can set that up. Let's just see if we can figure those out. So I want you to pause the video here, and using angle A, I want to see if you can find all the 6 combinations that we can get of one side over another side, okay? And I'll give you the first one. So let's try A over C. All right, pause it here and see if you can get the other 5 different ratios that we can create using this angle capital A. All right, pause here. All right, let's see what else we got. Well, we got A over C. We can also do C over A, the reciprocal of that. We have A over B, A over B. We can take the reciprocal of that, B over A. And finally, we have C over B, C over B. And we can also take the reciprocal of that, B over C. So notice that with this one acute angle, there's 6 different ratios that we can set up with different sides, and that is why we have 6 trig functions. Each one of the trig functions represents one of these ratios here. So using SOHCAHTOA, let's go ahead. SOHCAHTOA. It's just kind of a nice acronym, kind of like an acronym, in order for us to figure out what the ratios are going to be assigned to. This says that the sine is opposite over hypotenuse. So from this angle, acute angle A here, this is the opposite side, this is the hypotenuse side. So that the sine would correspond to that one right there. So this is the sine. All right, now notice if I was using the acute angle B, which I could, then the sine would be opposite over hypotenuse, it would be B over C. So remember, it depends on which angle, acute angle you're using to see which one the sine is. All right, so the next one is cosine is adjacent over hypotenuse, so that would be B over C. So B over C is right here, so this is going to be our cosine. Tangent is opposite over adjacent, so opposite over adjacent. Remember, the adjacent is always the non-hypotenuse side, so that one is A over B. So A over B is right here. And then the next 3 functions are all reciprocal functions of these. So the cosecant is related to the sine, and instead of opposite over hypotenuse, it's hypotenuse over opposite. So it'd be C over A, which is right here. So this is our cosecant, which is the reciprocal of sine. Cosecant and sine are just reciprocals of each other. And then the related trig function to cosine is secant, and that would just be hypotenuse over adjacent. So C over B, which is right here. So this is the secant, and it's just a reciprocal to cosine. And finally, we have tangent, which is our cotangent, which is the reciprocal of tangent, which is adjacent over opposite, which would be B over A. And we put the cotangent right here. All right, so that was a quick review on why we have trig functions and what they correspond to. Remember, it matters what the measure of this angle is and this angle, but we don't ever use C for SOHCAHTOA purposes. Big C angle, the right angle. All right, so now that we have all of that out of the way, let's go ahead and solve this problem here. So we have a point here. we draw a straight line from the origin to that point, and it says evaluate all of the trig functions of theta. So now theta is this angle right here. That would be in standard position because we're using the positive x-axis as our initial side, and then our terminal side is this one created by the origin and P. All right. So what we're going to do with this is we're going to create a reference angle with this. Now our reference angle is making a right triangle with the closest x-axis to our point. So either the negative x-axis or the positive x-axis. Now to this point, the closest x-axis is the negative x-axis, so we're going to draw a line going straight up. That was a horrible straight line. Let me actually use my, do I have a, all right, well, we'll just do it the best we can. All right, making a right angle here. Now notice that we have a right triangle. And this point is -4, -3. So from the origin, it goes 4 in that direction, and then it goes 3 in the negative y direction. So now we can figure out what this last side is because it's a right triangle, and we know the Pythagorean theorem, and that says a squared plus b squared is equal to c squared, where a and b are any two sides of our right triangle legs, and the c is the hypotenuse. And we're solving for c in this case, so c squared is equal to a squared, we'll call that 3, so that's 9, plus b squared, we'll call that 4, so that's 16. So c squared is equal to 25, and then we have to take the square root of both sides, so c is equal to, now remember we're only trying to find a distance here, so I'm only looking at the positive solution to this equation here, because normally it would be plus or minus 5, but in this case we're just going to use the positive one. So this length is 5. You may have already known that before we did it, because 3, 4, 5 is the most common special triangle that we have. Special triangles are triangles that have all integer solutions for the legs and hypotenuse. All right, so we have this triangle here. We're going to use this angle here as the reference angle. And then what we're going to do is we're going to use the fact that we're in the third quadrant in order to answer all of our functions or trig functions here. So what does that mean? It means in this third quadrant, my x is negative and my y is negative, which means that my cosine is negative, my secant is negative because it relates to cosine. Also, my sine is negative and my cosecant is negative because they also are negative, and cosecant is related to sine. But a negative divided by a negative, remember tangent is sine over cosine, and cotangent is cosine over sine. Since those are both negatives over negatives, we're going to end up getting a positive. So my tangent solutions will be positive, and my cotangent solution will also be positive. All right, so let's go ahead and do this right now. So the sine of this angle here, remember, we're using the reference angle, which will be the same as this entire angle, other than the fact that the sine might be different. So, that's why we need to make sure that we figure out the sines ahead of time. So the sine of theta is going to be negative something. The cosecant of theta is also going to be negative something. The cosine of theta will also be negative something. The secant of theta will be negative something, and then we have the tangent of theta, which will end up being positive, and the cotangent of theta, which is also positive. All right, so real easy. The sine is opposite over hypotenuse. So this angle here, that would be 3 over 5. So negative 3 over 5. The cosecant would just be the reciprocal of that. So 5 over 3. The cosine is adjacent over hypotenuse. That would be 4 over 5. 4 over 5. The secant is just the reciprocal of the cosine, so that's 5 over 4. And then tangent is opposite over adjacent. So that would be positive 3 over 4. And the cotangent is just the reciprocal, 4 over 3. And that's all of our answers. I hope it made sense. If you have any questions, let me know, and we'll take a look at one more. All right, for the next problem, I want to look at number 9. This is also on page 48. And it's to solve the equation with a sine of theta, where sine of theta is equal to negative 1. They want all the solutions between 0 and 2 pi, including 0, but not including 2 pi. So go ahead and pause the video, give it a try, and then we'll go over a detailed solution of it. All right, to solve this one, I'm going to go ahead and use a unit circle. And here is 1. So we want to look for all the solutions where the sine of theta is equal to negative 1 between 0 and 2 pi. So starting here and going in the counterclockwise position all the way back to that positive right x-axis. All right, so that's in a complete circle. So remember that the sine relates to the y-coordinate, so I'm looking for all the places that I have a y-coordinate equal to negative 1. And you can see here that the only place it is going to be 3 pi over 2. And that here is our answer. So we're going to say that theta is equal to, horrible theta, sorry about that, 3 pi over 2. Notice that they gave us this in radians, our restrictions. So we're going to put the answer in radians. Now, a lot of times we're going to have two different solutions. Negative 1 is one of the rare cases with positive 1 that we're only going to have one solution. But if they were to, for example, ask where the sine of theta is equal to 1/2, we're going to have right here and right here. So we'll have two solutions. If they ask where it's equal to the square root of 2 over 2, we'll have a solution right here and right here as well. But with 1 and negative 1, it's only going to happen once on that unit circle. Now let's see how we can actually do this in our calculator. So if I have my calculator up here and I clear out, make sure that I am in radians. And first thing I want to do is actually solve this. So if I start with the sine of theta is equal to negative 1, then I'm going to go ahead and apply the inverse sine to both sides. So the inverse sine of the sine of theta is just going to be theta. That's why we apply the inverse sine. And then we have to apply the inverse sine to this side as well, negative 1. Now, here is an issue. So let's go ahead and put this in here and see what we get. Oops, wrong calculator. So if I do the second sine, which is the inverse sine of negative 1, I'm going to get this value here. But notice the issue. This thing is not in terms of pi, and TI-83 and TI-84 calculators, which are required for this class, don't give us our answers in terms of pi. So we can check our answer very often, and sometimes it'll give it to us if we have an answer that's not in terms of pi, which happens. But if we get something like this, we really have to know what that's either equal to or check our other answer. So if I do the inverse sine of negative 1, so if I look at second square root, excuse me, hold on 1 second here. Sorry, 3 times pi divided by 2, Notice that I get this answer right here. This is approximately equal to 4.71. And if I subtract 2 pi from it, using coterminal angles 2 pi, I'll see that I actually get the same answer up here. Now remember, you can add or subtract any multiple of 2 pi and you'll get the same value because that's an angle pointed in the same direction. 2 pi is just a circle. So this is one way here that I can check my answer. Now if I were to subtract 2 pi and get an answer that's higher than this, and then subtract 2 pi again and then get an answer that's lower than this, then I know that this isn't one of my solutions here. All right, I hope this helped. Please make sure that you're taking good notes, and please also make sure that you are going through these sections just to review some of the stuff, and feel free to ask me any questions. Thanks.